So we'll continue looking at combinations. So that is where the order is not important. It's just the groupings. So we can do examples dealing with a standard deck of 52 cards, which has the following characteristics. There are 4 suits: clubs, spades, diamonds, and hearts. Each suit has 13 cards. 2 of those suits are black. Those are the clubs and the spades. 2 suits are red. Those are the diamonds and the hearts. Face cards are considered to be jacks, queens, and kings. So there used to be sometimes questions dealing with decks of cards on diploma exams, but not anymore. They won't put any questions involving decks of cards on the exams anymore because not everyone is familiar with them. But we'll still do some examples because everything we need to know is in this information. Poker's a card game played from a deck of 52 cards. How many different 5-card poker hands are possible? This is an example of combinations because it doesn't matter what order the cards are received in. At the end, you make the best hand you can with the 5 cards that you have. So this is combinations. There are 52 cards. You're getting 5. So there'd be 52, C5 different hands that are possible. So 52 C5. So 2,598,960 different hands are possible. Part B, then, we'll start talking about restrictions. How many different 5-card hands can be formed containing all diamonds? So this means that the 5 cards are only selected from the 13 cards that are diamonds. So it's 13 C5. And 13 C5 is 1287. How many different 5-card hands can be formed containing 4 black cards and 1 red? Well, it says above that half the cards are black, the other half are red. So 26 are black, meaning the first 4 will come from the 26 that are black. And remember, that means times the 1 red card comes from the 26 cards that are red. So this can be done in 2 separate steps, or you can do it all at once if you want. 26C4 times 26C1. 388,700 is the answer. All right. Question 3. How many different 5-card hands can be formed containing 3 kings and 2 queens? So there are 4 of each card in a deck. That means there's 4 kings. And from the 4, you're going to choose 3 of them. And again, means times, there are 4 queens in a deck. So from those 4, you're choosing 2. So again, this can be done all at once. 4C3 times 4C2. Gives us 24. For the last one, how many different 5-card hands can be formed containing 4 aces? So there are only 4 aces in a deck. You're going to get all 4 of them. So that's 4C4, which is 1. But then the remaining 1 card has to come from the 48 that are left. This is going to be 1 times 48. There are 48 other cards you could get. If you go 48C1, you're going to get 48. Okay, and 4C4 in your calculator will be 1. Number 2, a bag contains 7 black balls, 6 red balls. In how many ways can you draw groups of 5 balls if at least 3 must be red? So this would mean you're going to have scenarios. You're going to have 3 red and 2 black, or 4 red and 1 black, or all 5 red. At least means that many or more. So we've got some ands and some ors here. Remember, and means multiply, or means to add. So the first scenario is 3 red that are selected from the 6. Order doesn't matter. And mean times the 2 black are selected from the 7 black that are in the bag. So there's the first scenario, plus, because that's what or means. 4 red would be 6C4, and then 1 black, 7C1. Or 5 red coming from the 6 red that are in the bag would be 6C5. So we'll do each one. 6C3 times 7C2 is 420. 6C4 times 7C1 . Whoops. And then again, 6C4 times 7C1. That number is 105. And then finally 6C5 is only 6. So you'll add these up, which is 531. So that's how many 5-card hands a person could get with at least 3 red cards. Number 3, express these as factorials and simplify. So you would use the combination formula that's on the formula sheet. It says that NCR equals n factorial over n minus r factorial times r factorial. That is the combinations formula sheet that is on the formula sheet. So you don't have to memorize it. But you need to use it to simplify this expression. So the first part will be the numerator NC5. So that'll be n factorial over n minus 5 factorial times 5 factorial. And that is divided by n minus 1C3. So that will be n minus 1 factorial over. Now to get the first factor on the bottom, you have to subtract what's in front of the C and what's after the C. So that'll be n minus 1 minus 3 factorial times the 3 factorial. So just using the NCR formula. So I can start to simplify this. We know that dividing by a rational expression is the same as multiplying by its reciprocal. So we'll flip the second expression over, and the n minus 1 minus 3 will become n minus 4 factorial times the 3 factorial, and the n minus 1 factorial that was on the top now moves to the bottom because we're multiplying by the reciprocal. And now we want to simplify this expression. And we can simplify by expanding some of the factorials. And remember, the key is we need to get factors that are common on both top and bottom so we can cancel them. So if I look at what I have, on the top left I have an n factorial, on the bottom right I have an n minus 1 factorial. If I start expanding the n factorial, the first term would be n, The next one will be 1 less, which will be n minus 1. And that's where I'll stop. Remember, the last term in the expansion has a factorial on the end. So if we start with this n and do the next factor, which would be n minus 1, that's where we will stop. And we will stop there because on the bottom right, there is an n minus 1 factorial. So those will cancel. Okay, so what else can we expand? Well, on the bottom, I have an n minus 5 factorial. I can't really do anything with that. However, on the top right, I have an n minus 4 factorial, which I can expand. The first factor will be n minus 4. The next one will be 1 less, which will be n minus 5. And I'll stop there and put a factorial in the end because that will cancel with the n minus 5 factorial on the bottom left. Also on the top right, I have that 3 factorial. And on the bottom left, there's a 5 factorial, which I will also expand because that'll be 5 times 4 times, and I'll stop at the 3 factorial because that's what's on the top right. There's a 3 factorial there as well. Right? So now we will cancel. We'll divide top and bottom by n factorial. They go. We'll divide top and bottom by 3 factorial. They go. And we'll divide top and bottom by n minus 5 factorial. They go. So what are we left with? We're left with n and n minus 4 on top. On the bottom, you're just left with 5 times 4, which is 20. So there's the simplified expression. Okay, there's our simplified expression. We did questions like number 4 with permutations, NPR, and we saw that we could check our answer. We could get it by just guess and check. For example, NC2. If you tried 5C2, not big enough, we need to get 21, so we can try 6C2. Still not big enough, so 7C2. There we go. We know our answer has to be 7. However, a question like this on a diploma exam would be in a written response, and it would say determine the solution, which means you have to show your work. So we can do that again using the NCR formula. NC2 would be n factorial over n minus 2 factorial times 2 factorial, and that will equal 21. 2 factorial on the bottom is just 2 times 1, which I will multiply both sides by, which will give me 42 on the right. And then I need to simplify the n factorial over n minus 2 factorial by expanding the n factorial. It'll be n bracket, n minus 1 bracket, n minus 2, and that's where I'm going to stop with a factorial in the end because that's what the denominator is, n minus 2 factorial. They cancel, and we solve the quadratic that remains. It's n squared minus n equals 42, or n squared minus n minus 42 equals 0. You factor that, it'll be n minus 7, n plus 6, and n can't be negative 6 because n refers to the number of objects you're choosing from. Can't be negative, so the only one that works is our positive 7. That's the answer we got by using our calculator, guess and checking. Now we see where it comes from. Okay? So we'll do B the same way. It's got a few more pieces to it, but it's done the same way. 2 times NC2, which is n factorial over n minus 2 factorial times 2 factorial. And that has to equal n plus 1 C3, which will be n plus 1 factorial over n plus 1 take away 3 factorial times 3 factorial. Now in this case on the left, you have a factor of 2 on top, a factor of 2 factorial on the bottom, but 2 factorial is 2. 2 times 1. So those will cancel. And the next thing I will do is I will cross multiply, because these two things are equal. Whenever two ratios are equal, their cross products are equal. So I'll have the n factorial on the top left times n plus 1 take away 3 would be n minus 2 factorial times 3 factorial. That has to equal n minus 2 factorial times n plus 1 factorial. And we can divide both sides by n minus 2 factorial. They cancel. I'm going to keep the n factorial, 3 factorial on the left for now. And on the right, I can expand n plus 1 factorial. The first factor in that expansion would be n plus 1. The next one would be 1 less, which would be n, which is where I'll stop and put a factorial on the end. Because now I have a factor of n factorial on both sides, I can divide both sides by n factorial, and they're gone. So we're just left with 3 factorial on the left, which is 6, equaling n plus 1 on the right. Subtract 1 from both sides, and you have your answer, which we can check in our calculator. So the original expression is 2 times NC2. We found n to be 5, so 5 C2, that's 20. We should get the same thing on the right. When n is 5, the right is n plus 1, which will be 6 C3. Same number. So it checks. Number 5, during a Pee Wee hockey tryout, all players met on the ice after the last practice, shook hands with each other. How many players attended the tryouts if there were 300 handshakes in all? It takes 2 players to come together and shake hands, and that's done multiple times, in this case 300 times. We want to know what n is. What is n? Such that NC2, again, it takes 2 players to come together and shake hands. That's where the 2 comes from. So NC2 equals 300. So again, a question like this on a diploma exam, the expectation would be that you would solve it algebraically. So on the bottom left, you have a factor of 2 factorial, which is just 2. So we can multiply both sides by that 2, and that'll give us 600 on the left. We can expand the expression on the left to simplify. We would expand the n factorial. The first factor is n. The next one is 1 less, which would be n minus 1. And we could keep going as long as we want, but we'll stop with the next factor and put a factorial on the end, because that's what the denominator is. N minus 2 factorials cancel. So like before, we're going to get a quadratic that we need to solve. N squared minus n minus 600 equals 0. And the factors there would be n minus 25, n plus 24, And because n can't be negative, there's only the positive answer that would work, which would be 25. So if we check this, 25C2 should equal 300. And it does. How many ways can the debating club coach select a team from 6th grade 11 students and 7th grade 12 students if the team has 4 members? So again, this is combinations because the order the members are chosen doesn't matter. And in this case, they're just being chosen from the entire pool. You've got 6th grade 11 and 7th grade 12. That's a total of 13 students. 4 are being selected. So it'll be 13C4. 715 different combinations. Part B says, again, there's 4 members, but only 1 is in grade 11. So that means that 1 would be chosen from the 6 grade 11s, and the remaining 3 would have to come from the 7 grade 12s. So 6C1 times 7C3. $210. So again, we want to solve it or simplify this for question A. N minus 1C3 would be n minus 1 factorial over, remember the bottom has 2 factors. The first you get by going n minus 1 take away 3, which will be n minus 4 factorial times 3 factorial. And that'll be multiplied by 1 over n minus 2C3, which will be n minus 2 factorial over, again, the denominator has 2 factors, the first being the expression you get when you subtract n minus 2 take away 3. That'll be n minus 5 factorial times the 3 factorial. So, before we start expanding, let's simplify the second part of this, because you're dividing by a fraction. And that's the same as multiplying by the reciprocal, which means the 3 factorial and the n minus 5 factorial are going to come on top. On the bottom will be the n minus 2 factorial. It's 1 divided by that rational expression. You divide rational expression by multiplying by the reciprocal. So now, we can divide top and bottom by 3 factorial and they are gone. If you look at this and compare what you have left, you should realize that you've got to expand the n minus 1 factorial. The next factor in the expansion would be n minus 2. You put a factorial on the end of that, and that would cancel with this n minus 2 factorial on the bottom right. So we're going to have the n minus 1. The next factor will be n minus 2 factorial. We're also going to expand the n minus 4 factorial on the bottom, the first factor being n minus 4, the next being 1 fewer, which will be n minus 5. We'd stop there and put a factorial on the end, because there's an n minus 5 factorial on the top right. So n minus 2 factorials cancel, n minus 5 factorials cancel. And we are left with n minus 1 over n minus 4. So there's our simplified expression. Okay? Part B says solve for n if 720 times n C5 is equal to n plus 1 P5. Solve for n. So NC5 is n factorial over n minus 5 factorial times 5 factorial. And that must equal n plus 1 P5. So remember, for NPR, it's just n factorial over n minus r factorial. So this will be n plus 1 factorial over n plus 1 take away 5 would be n minus 4 factorial. So before I start expanding, I will cross multiply. So I've got 720 times n factorial times n minus 4 factorial equals 5 factorial times n minus 5 factorial times n plus 1 factorial. So on the right, we've got 5 factorial, which is 120. Let's see if the 720 on the left is divisible by 120 on the right. It is. It'll go 6 times. So we can start by doing that. Divide both sides by 5 factorial. That'll leave us with 6 there. If you compare what we have left, looking at the n factorial and the n plus 1 factorial, you'd have to expand the n plus 1 factorial. Because remember, the first factor is whatever is inside the bracket. The next factor is 1 less, and 1 less than n plus 1 would be n. Also on the left, you would expand the n minus 4 factorial. The first factor would be n minus 4. The next one would be 1 less, which would be n minus 5. Put a factorial on it because you have a factorial, n minus 5 factorial on the right side. So we've got 6 times n factorial times n minus 4 times n minus 5 factorial equals n minus 5 factorial times n plus 1 factorial will be n plus 1 times n factorial. So we'll divide both sides by n factorial. We'll divide both sides by n minus 5 factorial. And what we have left, 6 times n minus 4 equals n plus 1. Or 6n minus 24 equals n plus 1. 5n equals 25. So n equals 5. So there's a solution, which we can check. 720 times 5c5, which is going to be 1. So that's just going to be 720 on the left. And that should equal 5 plus 1, which is 6p5. Same number. So it checks. On the next page, I want to solve this one algebraically. So n minus 2c n minus 4. So the numerator would be n minus 2 factorial. On the bottom, we have two factors. The first factor comes by subtracting these two. So you are going to have n minus 2 minus all of n minus 4, and that's got the factorial on the end. But that's only the first factor on the bottom. Right? The first factor on the bottom comes by subtracting the n and r. But then you also have to multiply by r factorial, which in this case is n minus 4 factorial. And this whole thing has to equal 78. So let's simplify the bottom before we decide what we're going to expand here. Negative sign in front of the bracket changes all the signs inside. So this is going to become a negative n and a positive 4. It's going to be n take away n, which is 0, and then negative 2 plus 4, which is 2 factorial, times the n minus 4 factorial. So we can do a couple things here. We can multiply both sides by 2 factorial. 2 factorial is just 2. 2 times 1. Times 78 gives us 156. Also, I will expand the n minus 2 factorial on top. The next factor will be n minus 3, and the next one will be n minus 4, which will stop there and put a factorial on the end, because that's what the denominator is. And again, we multiply both sides by the 2 factorial, which will give us 156 on the right. So the n minus 4 factorials cancel. If we multiply out the quadratic that we have left, it'll be n squared minus 5n plus 6 equals 156, which we will bring over by subtracting 156 from both sides. And there's the quadratic that we need to solve, which we can solve by factoring. It'll be n minus 15, n plus 10. And because n can't be negative, our only answer would be n needs to equal 15. So there's our solution, and we can check it. When n is 15, 15 take away 2 is 13. When n is 15, 15 take away 4 is 11. So 13C11 should equal 78. And it does. So it checks. You're going to hand in these questions on page 534 to 535. And remember, I told you last class, Friday, June 9th, last day to hand in any missed assignments. Yes. Yes.